When we're talking about lines geometrically, one of the first things we're interested in is parallel lines. So lines that extend all along their length and never intersect. In coordinate terms, parallel lines will be lines with the same slope, which also means that in a coordinate plane, there's only one line parallel to a given line through a given point. That means in turn that if I give you an equation and a point, you can describe the line parallel to the line given in the equation through the given point. So in this example, we have this equation. So this is a line that we're being given. And we want to write the equation of the line parallel to that line through this point. The line was given to us in slope-intercept form, so we can look at this and see the slope. It's 2/3. A line parallel to that has the same slope, 2/3. And so we can write directly in point-slope form. Y minus the given y equals 2/3 x minus the given x. And that's all. That's all we need to do. If we really felt energetic, we could write x minus -4 as x plus 4 instead. That's all we need to do. We don't need to put it in slope-intercept form. We don't need to put it in standard form. We can leave it in point-slope form unless we have a compelling reason to want it in another form. For horizontal and vertical lines, so lines whose equations are y equals, that's horizontal, or x equals, that's vertical. Well, if we're parallel to a horizontal line, we're also horizontal. If we're parallel to a vertical line, we're also vertical. So in this example, we have y equals 7. That's horizontal. Y equals a number is a horizontal line. So the line that we want, that's parallel to that, is also horizontal. It'll also be in the form y equals. In this pair, y equals 4. So if we're going to pass through this point, we have to have the equation y equals 4. Okay, so much for slope-intercept form, so much for horizontal and vertical lines. What if we're given an equation in standard form and we want to find a line parallel to it? The standard method here is to rewrite in slope-intercept form to find the slope. So we'll subtract 2x from both sides and divide both sides by -3. And so the slope is 2/3. The line that we want will go through -2, 1. So we'll have y minus 1 is 2/3 times x minus -2 is x plus 2. But let's see what happens if we take that and put it back in standard form now. So we'll distribute. We'll get all the variable terms on the left, all the constant terms on the right, and then we want the coefficient of x to be a positive integer. To make that happen, we need to multiply both sides by -3. So we'll have 2x minus 3y equals -7. And the thing that we notice here We have 2x minus 3y. We started with 2x minus 3y. It turns out it's pretty easy to see that that's always going to happen. If we have a line in standard form and we want a parallel line, we keep the same coefficients. How could we find that -7? Well, we want to have x equals -2, y equals 1 be a solution. So 2 times -2 minus 3 times 1 equals -7. Well, then the right-hand side must be -7. We can plug in to find the constant. Now, if you don't remember to do that, solving for y and finding the slope, and then writing down the point-slope form is also a correct method. But if you do remember to do that, you can save yourself a lot of effort and be able to just write down the equation of a parallel line in standard form.